Polynomials. Our objective is to classify polynomials and write polynomials in standard form, as well as evaluate polynomial expressions. Who uses this? Pyrotechnicians can use polynomials to plan complex fireworks displays. Let's start with a monomial. A monomial is a number, a variable, or a product of numbers and variables with whole number exponents. So for example, 5x, negative 7xy, 0.5 x to the fourth. Notice how a monomial doesn't have an addition or subtraction sign between things. Like this has two terms in it. A monomial is just one term, one clump of numbers, if you will. So these are some examples of not monomials. Negative 0.3x to the negative second power, or 2 divided by x to the third. You have your variable in the denominator. So now the degree of a monomial is the sum of the exponents of the variables. A constant has a degree of 0. So once again, this is for a monomial. We're going to be talking about polynomials, for example, things like binomial and trinomial. A monomial means one term, so one little clump of numbers. No addition or subtraction between them, no negative exponents, nothing divided by a variable. And then to find the degree of it, we add up all the exponents. So like if you looked here, we have negative 7xy. This would be to a degree of 2, because it's like x to the first and y to the first. So a degree of 2 for this monomial. Let's practice a little more. So finding the degree of a monomial. So we have negative 2a squared b to the fourth. Notice how it's one clump of numbers, no variable as a denominator, no negative exponents. So when you see this, you know that you can simply add all of your exponents of your variables. So we have 2 and 4, which make 6. There are no variables with this number 4. If there are no variables or letters of the alphabet, for example, here, that means the degree is 0. Because if you had x to the 0, that's like saying 1, right? So 4 times 1, that kind of gets you back to your 4. That's why the degree is 0. So now let's look at C. We have 8y. We talked about it when we were looking at our monomials here. Like when there isn't anything written, it's assumed that it's x to the first. Because if it was x to the 0, it wouldn't even be there at all. So the degree is 1. A polynomial is a monomial or sum or difference of monomials. So now you're starting to add or subtract these terms here. The degree of a polynomial is a little different than the degree of a monomial. The degree of a polynomial is the degree of the term with the greatest degree. So in this case, you're not going to have two different degrees, and you're not just going to take the smallest, you're going to always take the largest. This way, everybody always has the same result. So, for example, we have 4x minus 18x to the fifth. 4x, the degree of this monomial, is 1. Then we have this negative 18x to the fifth. The degree of this one is 5. So which one is the biggest? 5. So the degree of the polynomial is 5. Let's try these two. So we have 0.5 x to the second y plus 0.25 xy plus 0.75. So the degree of this first one is 3. The degree of 0.25 xy is 2, because you have x to the first, y to the first. And then this is a constant. There are no variables next to it, so it has a degree of 0. Well, to decide what degree it is, you take the biggest one. The biggest one is 3. So the polynomial has a degree of 3. Try C on your own. Now that you've had a chance to try C on your own, let's see how close you came. So we have a degree of 4, 2, 1, and 0. So the largest one is 4, so it has a degree of 4. So the standard form of a polynomial that contains one variable is written with the terms in order from greatest degree to least degree. For example, we have negative 4x to the fifth plus 9x to the third minus x squared plus 16. Notice how the greatest degree comes first, and then they get smaller as they go down. Your leading coefficient is when you have the polynomial is written in standard form, so kind of like it is right here. The leading coefficient is the coefficient of the first term. So negative 4 would be this one. Let's practice. So we're going to write polynomials in standard form, and then we're going to give the leading coefficient. So for this one, we want the greatest degree, so we're going to start with negative 4x to the third. The next greatest one is going to be this x squared, so we've got minus x squared. If you're wondering whether to have a minus or a positive, so a subtraction or an addition, it's whatever sign comes in front of the number. So this was a negative, so it's minus 4x to the third, so it's going to be a negative 4x to the third. So then our next one, we've got a positive 20x, so we got plus 20x, and then we end with plus 2. The leading coefficient is the coefficient of the term in front, leading. So we've got negative 4 in this case. Let's try this next one. So we have our greatest degree would be y to the fifth. The next greatest degree is going to be a positive y to the third. And then the next one is going to be a positive 4y. However, what is the leading coefficient? There's no number there. You can always assume there's a number 1 in front, because you have 1y to the fifth. Not 20y to the fifth, but you have one of them because it exists. So your leading coefficient is 1. Some polynomials have special names based on their degree and number of terms they have. So let's start with degree. So we have 0, 1, 2, 3, 4, 5, 6 or more. So if the degree is 0, it's a constant. If the degree is 1, it's linear. So this would be like saying x. This would be like saying the number 3. This would be like saying x squared, because the degree is 2. So that's quadratic. If the degree is 3, that's like x to the third. That's cubic. A degree of 4 would be like x to the fourth. So that's quartic. And then quintic is a degree of 5. Once you get more than that, so once you go to 6 and keep going, you can just say it's a 6th degree polynomial or a 7th degree, and so on. You just use the number. Quadratic and cubic come up a lot. That's why they're highlighted here. Alright, so what about terms? When you name a polynomial, it gets a name for the degree and a name for the term. So if it has one term, it's a monomial, just like we talked about at the very beginning of the video. If there are two terms, meaning like you had x plus 3, that's a binomial. A trinomial means you're going to have one more term in here. So maybe you have an x squared out in front. So there are 3 terms, so it's a trinomial. Once you get to 4 or more, you just say it's a polynomial. Let's practice. So our first one, we have 5x minus 6. So we're going to use a degree and a term to name these. So let's start with the degree. Well, the degree of this polynomial is 1. So if the degree is 1, it's going to be linear. And then there are 2 terms. So since there are 2 terms, it's a binomial. So you just kind of write it together now. So it's a linear binomial. There's 1 degree, 2 term, linear binomial. Try the next 2 on your own. Now that you've had a chance to try the next 2 on your own, let's look at them together. So let's start with the degree. The degree is 2, and there are 3 terms. So since it's a degree 2 and there are 3 terms, we are going to state that it is a quadratic trinomial, because degree 2 means quadratic and 3 terms means trinomial. So now let's look at C. C is a little complex. We have 6x to the 7th plus 9x squared minus x plus 3. Well, the largest degree is 7, and there are 4 terms. When this happens, remember what happened at the bottom of our grids. We had 6 or more, we were just going to say 6th degree, 7th degree, or if we had 4 or more, we were just going to use polynomial. So, it's a 7th degree polynomial. Since the degree is 7 and there are 4 terms, it's a 7th degree polynomial. Now let's try a physics application. A firework is launched from a platform 6 feet above the ground at a speed of 20 feet per second. The firework has a 5-second fuse. The height of the firework in feet is given by the polynomial negative 16t squared plus 200t plus 6, where t is the time in seconds. How high will the firework be when it explodes? Hint: substitute the time for t to find the firework's height. So, substitute it in. We have negative 16, 5 squared, plus 200 times 5, plus 6. So we've got negative 400, and then we have 200 times 5, which is 1,000, and then we add 6, which leaves us with 606. When the firework explodes, it will be 606 feet above the ground. And that ends our video lesson on polynomials.